Hi everyone, I'd like to welcome you to Mr. Q Does Math, the video show where Mr. Q, that's me, does math problems. What we're going to be doing today is factoring quadratic equations. Just to review, the standard form of a quadratic equation is read ax squared plus bx plus c equals 0. Before we do any specific problems, I wanted to take a look at a binomial expression expanded and how it relates to a factored quadratic equation, because there's something really interesting that we find that basically allows us to do all the problems in the future. So as we have it right now, x plus m times x, the quantity x plus n. So to expand this, we're just going to use the FOIL method, which is first, outside, inside, last, and those refer to the terms that we multiply together. So first here would be give us x squared, x times x would be x squared. Outside would be x times n. Inside would be m times x, and last would be m times n. Okay, and then right away here I can see that we have an x here and an x here, so we can factor that x out, so we can rewrite the whole equation as x squared plus x times the quantity n plus m plus mn. Okay, and now because of the commutative property of multiplication, I can also rewrite this as x squared plus the quantity n plus m times x plus m times n. And by writing that, I want to compare it now to a equation in standard form, which is ax squared plus bx plus c equals 0. And what we see is that this a corresponds to the coefficient in front of x squared, so for this given problem it would be 1. The b corresponds to n plus m, and the c corresponds to m times n. So what this means for us is that if we have the factors of a quadratic equation in this form, in m plus n, m and n as our variables, we can plug these in to be able to write our equation in standard form. Or we can work backwards, and if we already have it in standard form, we can find that b is equivalent to n plus m and c is equivalent to m times n. If that doesn't make sense right away, don't worry, we're going to do some examples that will show how it works. We can now check if the pattern we found above can be used to go the other way when you already have a quadratic equation, and to find the roots and put them in a parenthesis form, which should look something like x plus some quantity times x plus some quantity. So, looking back here, so our coefficient for a is going to be 1. B is equal to m plus n, and in this case, our m plus n equals 5, because it's the coefficient in front of the x power by itself. And c is going to equal m times n, which in this case is going to be 6. So what we need to do is solve two different equations at the same time. We need to find two numbers that add to 5 and multiply to 6. So we need to find two numbers that multiply to 6, and add to 5. So first, let's think about what kind of numbers can multiply to 6. What kind of numbers multiply to 6 basically is telling you what factors are there that can, what are the factors of 6. So factors of 6 are going to be 1 and 6, because 1 times 6 is 6. 2 and 3, because 2 times 3 is 6. 3 times 2 is the same as 2 times 3, and 6 times 1 is the same as 1 times 6. Now, of these factors that multiply to 6, which add to 5? Well, the sum of this is 7, 1 and 6. And over here, 2 plus 3, that adds to 5. So now we have two numbers, 2 and 3, that multiply to 6 and add to 5. So that is going to be where our solution comes from. And because we know that it should look like it's in this form, we can just say that x plus 2 times x plus 3 is the solution to that problem. To check it, it's really simple. All we have to do is FOIL and expand it out. So first, x and x is x squared. Outside is going to be 3x. Inside is going to be plus 2x. And last is going to be 2 times 3, which is 6. Combine like terms as always. X squared plus 5x plus 6. And that is the same as what we started with. So we know that these are the factors of x squared plus 5x plus 6 equals 0. And when the question asks you to solve, you want to write your answer as x equals -2 and x equals -3. The reason for this is because of the zero product property. The gist of the zero product property is that when you multiply two values together and set them equal to 0, you have both of them equal to 0. For example, if you have some quantity A, you multiply it by some quantity B, you set that equal to 0, then that means no matter what A is, B is going to be 0, and no matter what B is, A is going to be 0. Because let's say, for example, your A was 1. 1 times some number B is going to equal 0. So this B would then have to be equal to 0. Or, if your A was 5, B still has to equal 0. Or if you had an A value, you multiplied it by 6, A would have to then equal 0. So either way you look at it, one of the values has to be 0. And that's the gist of the zero product property. With the zero product property, all we did is take our solution and set both values equal to 0. So x plus 2 equals 0 and x plus 3 equals 0. And we just algebraically solve this. To get rid of the 2, we want to subtract it from both sides. So we have x equals -2. And over here we want to get rid of the 3, so we subtract 3 from both sides. And we get x equals -3. and that would be our final answer. Now that we kind of have an idea as to why we're doing what we're doing, let's work on some examples. And my recommendation for this part of the video is that once I write down the problem to do, you should pause the movie, work on the problem on your own, and then check to see if your work corresponds with mine and that we're getting the same answer. That would be the best way to use these videos. With that being said, let's do it. So our first problem is going to be to factor x squared plus 14x plus 24. Okay, so back to how we thought about this. This is going to be our a value over here as a coefficient of 1. Our b value is going to be 14, and our c value is 24. And all that's referring back to is the standard form of a quadratic equation. So since the b value is going to be 14, we know that m plus n equals 14. And c is 24, so we know that m times n is going to equal 24. So we know that these numbers are going to multiply to 24, so let's start by finding the factors of 24. One and 24 multiply to get 24. 2 and 12 multiply to get 24. 3 and 8 multiply to get 24. 4 and 6 multiply to get 24. 7, nothing works. 8, we're back to 3, so that means we found them all. Now, we need to find numbers that multiply to 24 and add to 14. So let's look at the sums of all these values. 1 plus 24 is a sum of 25. 2 plus 12 is a sum of 14. 3 plus 8 is the sum of 11. 4 plus 6 is the sum of 10. So back to what we were looking for up here, we need two numbers that multiply to 24, which are all these, and add to 14. I only see one set that works over here, and so this is going to be our solution set. So we just add our open parenthesis, x plus 2 and x plus 12. And just to check it real fast, make sure that I got it right, I'm going to use the FOIL method. First, x times x is x squared. Outside is plus 12x. Inside is plus 2x. And last is 12 times 2, which is 24. Combine like terms, and we get x squared plus 14x plus 24. And that checks out with up here, which means x plus 2, x plus 12 is the solution.